Okay, guys and girls, welcome back to another fun-filled, action-packed, non-flipped Algebra 2 classroom video with me, Coach Goo. This is Unit 13 Notes number 2 because this is the second set of notes that we're doing, and it is going to be about rationalizing the denominator. Rationalizing the denominator. What does that even mean? So, general rule is you can't have a radical in the denominator. All right, so look at this very first example. It says, what is the simplest form of square root of 9y over square root of 2x? So based on what I just said, what's wrong with that term right there? There's a square root in the bottom is the right answer, right? You're not allowed to have these square root symbols or this symbol at all in the denominator, in the bottom, okay? So we use this process called rationalizing the denominator, which means pretty much that you're getting rid of the square root sign or getting rid of the radical, okay? So how do we do this process? It's actually not that difficult. All you have to do is take your original fraction, or original term, square root of 9y over square root of 2x, and you're just going to multiply by the radical term in the denominator, which is what? What? Yeah, what is the radical term that's on the bottom right now? What's the whole thing? Square root of 2x. So you're going to multiply the top and the bottom by square root of 2x. You have to do the top and the bottom because square root of 2x over square root of 2x, that's technically 1, right? You're not really changing the value like that. And why would we do that? Do you have any idea why I would multiply by that number? Because that would cancel out the square root sign in the bottom. That's right. So when I multiply like this, the bottom, the square root symbol just is canceled out. So it's just 2x. But what would be on top then? 18xy. Square root of 18xy. That's right. Don't forget the square root sign on the top. Right, so if you're curious how that works, like think about it this way. The square root of 9 times, or let's do it in general terms. Square root of x times square root of x, right? I'm multiplying a square root by the exact same square root. What does that give me if I multiply square root of x times square root of x? Square root of x squared, which is x. So you see, by multiplying the exact same square root, all that happened in the very end was the square root sign is gone in the end. Do you see? X could be any number. So that's why we do this rationalizing the denominator. Okay, so that was the first step. And the second step is to actually then just simplify. Because right now, the 18, I can pull some values out of the radical, and some would stay inside. Okay, so what is going to be on the outside of the radical with the 18? Let's see by using the upside down division. 18, what can I divide 18 by? 2, that gives me 9. What can I divide that by? 3, that gives me 3. What can I divide that by? 3, good. And that's where it stops. And how big are the groups that I should be looking for? 2, right, because the index is 2. So here is my only pair. So that comes out as a single 3, which means what is on the outside of my radical now? 3, and what's on the inside? 2. Right, the 2 that was not used. And what else was there to start with? X and y, right? Those can't leave because they only have an exponent of 1. And over 2x, right? And that is your simplified answer because there's no more radical, there's no square root in the bottom, right? And also, you can't reduce anymore. 3 over 2 is as much as you can reduce by. So that's going to be the answer. And that pretty much is the process of rationalizing the denominator. You're trying to make sure there's no square root, no radical in the bottom. Okay, so let's take a look at some other examples. These are starting very basic. Example 1, 3 over square root of x. Square root of 6. I don't want the square root sign on the bottom, so how can I get rid of the square root sign on the bottom on example 1? Times square root of? That's right. And this would equal what? So on the top, you can't actually multiply the 3 and the 6. Right, 3 square roots of 6, because the 3 is not inside the radical. So you just write it like this, 3 square roots of 6 over what? Over 6, that's right. But now notice, right, you always want to check to see if you can reduce. Can I reduce this 3 square roots of 6 over 6? To 1/2, that's right. And so that would end up being what? Right, 1 square root of 6 over 2. I don't need to write the 1 next to the square root of 6, right? It doesn't really change anything. So my final answer would be square root of 6 over 2. All right, let's take a look at the second example then. On the second example, what do I do to get rid of the square root on the bottom? Times what? Just x? Square root of x, right? Don't forget the square root. And if I multiply the top and the bottom by square root of x, what's on top now? Square root of 5x. Do not forget the square root. What's on the bottom though? X. That's right. And that's as simple as it gets right there. You can't reduce anymore. So that's it. Let's take a look at example 3. What do I need to multiply to get rid of the square root on the bottom here? What is it, Holly? Square root of 2x. Thank you. There we go. So that gives me what on top? Right, so don't make the mistake of combining the 6 and the 2, right? Because the 6x, there's no radical, you see? So you can't actually multiply them together. So you just write it straight across, 6x times square root of 2x. But what's on the bottom? 2x. Yes, so now we can simplify this. What would this reduce to? 3 over 1. So just 3. 3x? Just 3 square roots of 2x, right? Because look right here. 6 divided by 2 is? 3. There's a 3. X divided by x is? X divided by x is 1, right? Which doesn't do anything when you're multiplying. So that's just canceled out. And then just the square root of 2x. Whoa. Yeah, so this is the answer right here. 3 squares of 2x. Okay, so those examples are not too difficult, but let's look at examples 4 through 6. These examples, you're going to want to simplify before rationalizing the denominator. Otherwise, you're going to get very big numbers, and it's going to be really annoying to work with. So whenever you can simplify before, you want to do that first. So what do I mean by that? Remember yesterday and the day before, we were doing dividing and multiplying radicals. So right here we can divide because the index is the same on the top and the bottom. It's both 2. So if I wanted to reduce the 4 over 14, what does that reduce to? 2 over 7, that's right. So I can reduce this to 2 over 7. Makes it a little easier to work with. But now let's continue with the division. The x on the top, is there anything to divide by on the bottom for the x? No, so I'm just going to put the x back on the top right there. But now I have y cubed divided by y squared. What is that? And should I put that on the top? Yes, because the bigger exponent, y cubed, was on the top. So now you can see that by simplifying, we've changed our equation to just square root of 2xy over the square root of 7, which makes it a lot easier to rationalize the denominator. So what do I need to do here to get rid of the square root sign? Multiply by square root of 7, that's right. And when I do that, what is left on top? It's 14, right. We can multiply those. Because they're both under the radical, so we can just multiply. 14xy, that's right, over? That's right, and that's the final answer. You can't simplify any more than that. Because we simplified at the very beginning, when we get to the end, we won't be able to simplify anymore. Theoretically, anyways. All right, so example 5. Same thing here. We want to reduce beforehand. So can I reduce 20 over 6? Yes. To what? 10 over 3. 10 over 3, that's right. Okay, now let's take care of the a terms. Notice a squared, the bigger exponent, is on the bottom. So where's my a going to go? On the bottom. And what's the exponent on the a going to be? A. Just a, right? Because a squared divided by a is just a, and you're going to put it on the bottom because the exponent was originally bigger on the bottom. So now we're just here. Square root of 10 over square root of 3a. So how can I get rid of the square root on the bottom? Thank you. Multiply by square root of 3a, right. So what's on the top now? Square root of 38 over a. Over 3a. That's the answer for number 5. All right, now that's already simplified, right? So here is another strategy you can use to simplify. On number 6, notice that you can actually pull some numbers out of the radical at the very beginning. Okay, 6x over square root of 4x. But what's the square root of 4? 2, right? So when you see something like that, you want to just go ahead and pull it out of the radical at the beginning. It's going to make things easier. So we have 6x over 2 times the square root of x. And so now, what do I need to multiply by to get rid of the radical on the bottom? Just the square root of x, right? Because the only part that's in the radical is just the x, right? So we only need to multiply square root of x. And so when I multiply by square root of x, what is on top? Right, 6x squared of x. Once again, we can't combine them because 6x is not in a radical. What's going to be on the bottom? 2x, right, 2x. The 2 was already just numbered there, and the x, now we get rid of the square root sign. And so there it is, 6x times square root of x over 2x. And does this simplify more? Yes. To what?
3 square root of x.
3 square root of x, that's right. Because 6 divided by 2 is 3. X over x, 1, so it cancels out. And then just the square root of x. And there we go. Now let's go to the back side and take a look at some special examples. Yeah, special. We've been working with square root this whole time, but now what if we have different roots? This is a cube root. But also, keep in mind, you always want to simplify first, because sometimes that will solve your question right away without even having to do rationalizing. So let's simplify first. If I divide 16 by 2, what do I get? 8. Okay. But then I have the a terms. What is going to happen with my a terms here? There's an a on top and then an a to the 4th on the bottom. A cubed on the bottom, right. Because we can subtract the exponents, 4 minus the 1, and that's 3, but it goes on the bottom because the exponent was bigger on the bottom to start with. And what about my b terms? B on the top, that's right. Because the 2 minus the 1 is just 1 is my exponent. There we go. And that's very helpful because, look, this is going to simplify immediately without even having to do rationalizing the denominator. Okay, so what is the cube root of 8? 2. So we have 2 cube roots of b. The b can't leave, right? Over a, that's right, because the cube root of a cubed is just a. So notice, because we simplified, we got our answer immediately. And on to the last example of the day. This one is special. You need to know how to do something like this. All right, so first let's simplify, though, because I can see that it's 2 over 20, which can be reduced to what? 1 over 10. 1 over 10x. Okay, now, what is the cube root of 1? 1. So this is now just 1 over the cube root of 10x. Okay, so I want to get rid of the radical on the bottom, okay? So it's cube root of 10x. So what do you think I would do to get rid of that cube root radical? Multiply by what? Square root?
Cube.
Yeah, make sure you're paying attention to actually what your index is. So I multiply by the cube root of 10x, is that what you're saying? But think about this. With the square roots, we multiplied it twice, right? And that canceled out the square roots. But this is not a square root. This is a cube root. So what do you think I would have to do? Because this is not actually enough. How would I get rid of 8 cubed? Multiply by what?
Another cube root.
Right, multiply by it again.
Wait, why would you do that?
Take a look at this. Watch this example. That is a good question. Why would I do that? So look at this example right here. So originally you said to do this, right? Something like this, where you're multiplying by itself. But what does this equal? What's under my radical now?
A squared.
Is that enough to bring it out? No, right? But what if I multiply again by one more? Now you have x cubed, and what is the cube root of x cubed? X. So do you see? You have to have multiplied 3 times now to get it out of the cube root. Okay, so that's why we multiply, you see, 1, 2, 3 on the bottom. Okay, so what's going to be on the top, though? Since I multiplied these 2 terms together.
3 square root of 20x.
You mean the cube root? Cube root, right? Of
20x squared.
100, we're multiplying, remember?
Oh,
100 and then x squared, right? Over
Over cube root over 100.
well, what was the point of multiplying 3 of the same thing?
oh.
It cancels out.
So it'd be
It's just 10x, that's right. Like that. So if I had an index of 4, how many times would I have to multiply it by?
Can you separate and then we simplify that?
3 more times, you mean? Yeah. And you can't simplify this, no. Because if you wanted to check, right, you can do the upside down division, right? And let me just do it really quick for you. This would be the upside down division, right? Showing you the prime factorization. But how big are the groups supposed to be? 3. Do you see any triples here? No, so that's why this is a simple, yeah, exactly. So as simple as it gets, that's the answer. And that's,
So in order to not see like simplify again.
yeah, if you're not sure, then do the upside down division and see if you have any groups. But that's going to end these notes, guys, about rationalizing the denominator. So see you in the next one. Peace!